In this lesson we're going to look at how to calculate the area between two graphs or two functions. So far we've just looked at how to calculate the area trapped between one function and the x-axis, whether above or below the axis or both at the same time. Now we turn our attention to this idea in the diagram here. This green area trapped between this blue function, which is a parabola, and the red function, which is a straight line. Now in order to do this calculation we need to understand that integration calculates the area trapped between the function and the x-axis, between the limits that you define, so -3 and 1 in this case. So if we were to integrate the parabola, the 9 minus x squared, between -3 and 1, then what would this calculate is area 2 all the way underneath down to the x-axis. But we don't want all of that area, we just want this part here. So what we need to do is get rid of this triangular part here, like that. And in order to get rid of that, we work out area 3, we integrate under the straight line between -3 and 1. So this is a technique. You just change that back. You work out area 2, you work out area 3, and you do a takeaway. Now, the first area is always calculated from the upper function. What we mean by the upper function is the function which is highest up between the -3 and the 1. So if I'm looking at this here, part between -3 and 1, I'm looking to see which point's highest to find the upper function. So if I look at this point here, say that was -1, and I go up, then the red function is lower than the blue function. Over here as well, the red function is lower than the blue function. So that counts as our upper function, the parabola. And the red function counts as our lower one. So it's always highest function take away lowest function. So let's look at how we would do that. Now I've wrote some instructions down here. Make a sketch if one's not shown. Calculate the area between the upper graph and the x-axis, in this case the parabola, and then calculate the area between the lower graph and the x-axis, in this case the straight line, and then subtract the two areas. So, upper area, that's the parabola between -3 and 1. So the upper limit's 1, the lower limit's -3. The lower area is the straight line, and again upper is 1 and lower limit's -3. If we can do this accurately and correctly and then do the takeaway, then we've got our answer. So integrate 9 minus x squared, so the 9 is going to go to 9x, the x squared, add 1 to the power to get 3, that's a third x cubed, so we have this. Sub in the 1 to both bits, do a takeaway, and then substitute in the -3 to both parts. And that's going to come out looking like that. So 9 times 1 is 9, 9 take away a third, so that's going to be 8 2/3. This is going to come to -27. That's going to go to -27. A third of -27 is -9, that's going to go to a +9. So -27 plus 9. And that comes to 26 2/3. You're going to add on 27 and take away the 9. Or you could just do this calculation here. -27 add 9 is -18. So we add on 18 to this, take away -18. So 18 plus 8 is 26, and then you get your 2/3. Okay, our lower area, if we integrate x, we get, add 1 to the power, you get 2, so a half x squared plus 2x. Sub in the 1 to both parts, do a takeaway, and then sub in the -3 to both parts. It's going to look like this. So we're going to get a half times 1 plus 2 times 1, so that's 2.5. In this part we're going to get negative 3 squared, and that's 9. So half of 9, that's going to be 9 over 2, take away 6. So 4.5, 9 over 2 goes to 4.5, take away 6 if you like. So 4.5 take away 6 is negative 1.5. So 2.5 take away negative 1.5, that's going to be 2.5 plus 1.5, which comes out as 4. So remember, to get this area here, you do the area under the upper function, which is the blue one, or the parabola, and you subtract the area under the lower function, which is a straight line. So we're going to do upper area minus lower area. 26 2/3 take away 4, it's 22 2/3.